Today I wanted to do a sort of show and tell on a project that I'm working on with a friend of mine, and it's based on a shared interest of ours, which is this board game, which many of you already know I'm interested in, called Go. And it's an ancient East Asian strategy game that involves two players alternating turns, trying to beat the other, obviously. We wanted to create this game and make it playable online between two players, in their browsers anywhere. And so we decided we were both interested back when we started in learning about React. So the front end is React, but we didn't want to mess around with a lot of back-end and database, stuff and configuration and whatnot. So we looked into Firebase as a very simple, easy-to-use, out-of-the-box solution for this kind of application. And so the name of our project is Tenuki, which is a Go term, which means play somewhere else. So that's the name of our project. Anyway, before we get into the technical stuff, I wanted to go over the rules of the game and a sort of description of the game. And as I talk through this, maybe we can think about how we would represent this in a piece of software. So the first thing is that it takes place on a 19 by 19 grid. So that means that we'd have to somehow visually represent this to both players and have them be looking at the same board state at any one time. As I mentioned before, there are two players who, tightly linked with that is the fact that they alternate turns. So that means that one player has to be prevented from playing on the other player's turn and vice versa. So that's another technical concern to take into account. In terms of the actual gameplay, stones are placed on intersections and they do not move. So you can imagine from one board state to the next, you would have the stones stay in one place, or stay where they are. There's one exception to this rule, which is when stones are removed from the board, and that happens when they are surrounded, and these stones become captured stones for the killing player, so to speak. So the stones don't actually move on the board, but they either are placed or removed. There are two rules that exist in the game, but that we were not considering from the outset because we wanted to keep the scope, manageable when we're just starting to build this from scratch. And one of them is that at the end of the game, territory is counted. This is done by counting intersections, which is where the stones are placed as well, that a player surrounds, and that's kind of a difficult task in itself. So we decided to defer that till later. And the other one is a rule called the co-rule, which basically means that the board state cannot be repeated 2 moves in a row. So if black plays one move and then white responds, black cannot play the very same move that he played before, which in the case of a capture can arise in a real game, but it's kind of rare. So let's turn now to Firebase, which is as I mentioned before, the database solution put out by Google or acquired by Google a couple of years ago, I think, that we decided to use. As you can see from this image taken from their website, Firebase offers a lot of options, or a lot of a rich variety of offerings here. But we're really only using one of them, and that's the Realtime database, which I've circled there. We can take a look at this slide to get more of an idea of how this database is structured, and the important thing to glean from this is that it's a NoSQL database, something that I've never worked with before. But it is all structured as JSON, which I think that we're all familiar with, and so that's kind of an easier way, or a simple way to take a look at data. Of course, the first thing that comes to mind when considering this is that relations between tables, as we're used to in SQL, don't exist in quite the same way in JSON, or can't exist in the same way in JSON. So that's handled differently. But with a game like what we're designing here, that is less of an issue, I guess, because it seems to be probably more of a simple structure of data, I think. So we're going to jump into a little bit of code just about how we set up our Firebase in our game app. And these are some methods that we're going to use that are all pretty reasonably named, by which I mean we should probably be familiar with what they do. But I figured we can take a look at them anyway. This is from their documentation. The first is child, which, as you can see here, you can pass a relative path, and it will return what they call a data snapshot of that path of what's there. And then at the end, you can see if the child location has no data, then null is returned, or an empty data snapshot is returned. Then we go to on, which is also probably familiar to many of us, which just listens for data changes at that particular location. And then finally, child added, which used in conjunction with on, you can listen for when a new child is added to a data snapshot or to your database in general. And as we'll see in the next slide, the data snapshot passed into the callback will reflect the data for the relevant child. So here's where we use these methods. And we can see at the top, line 8, we instantiate a new Firebase that we got access to by going onto their website and signing up. And so we're called Crackling Heat 815, a very nice name. And then below, we can see that we create a game reference, and they use this terminology reference to reference the various parts of the database that you can interact with. And we can see that it's called games/game ID, which is just a very long number that we generate to differentiate games. So let me move down, and this will be familiar looking to those of us who have used React before. But we can see that when the moves component mounts, and I should step back and say this moves component is going to be shown on the screen as simply a list of text of the moves, which if we skip down to line 38, just shows the date it's created, the type of move, which is always going to be click in this case, but we want to leave it open for moves that get placed in other ways, and the x and y coordinates of each move. So, moving back up, we see that the game ref, or reference to the game itself, we, on child added in the moves path, you might say, the move snapshot has a value which we've populated elsewhere in the code, and then if we look down to how we set the state, we concatenate each move into this list of moves as they're added as children. So here this is where we show pushing a move into the list of moves. And we can see from line 50 through 54, this is the structure of each move. We have our date created, the type, which as I mentioned will always click for now, and then our x and y coordinates. This is just a nifty UI that they give that shows the structure of the data, and you can see the ID at the top, 1302, etc., is the game ID, and then the moves information for each move, each of which has its own, long string of nonsense, has date created, type click, x and y. So I've opened up two moves here that happen, one after the other. And this is the end result. This is how the game looks right now. We're not finished with it, not by a long shot actually, but you can see on the right the game ID and then each move that's been placed in this particular game. And so really all I've covered is the interaction with the database and excluded the interaction on the front end, which I created here with the help of SVGs, and these little stones are actually emojis. So that's pretty cool. Which also means when you change the size of the window, it scales pretty well. Yeah, so I just thought that it would be fun to take a look at this game that we're developing and give you a little snapshot, so to speak, of where it is right now. Thanks.